Hi everyone, it's Has. I'm going to continue with our tutorial, all right? So the today's topic is going to be nonlinear static analysis. As we know, it's going to be on Patran Nastran, and I'm going to show you the large deformation of a cantilever beam. I think this is the best way to start our tutorial. First of all, I'm going to create a new file. Here is going to be nonlinear. Let me use the underscore, right? I think it's better. Nonlinear static analysis. Okay, static analysis. I think this is better. I'm going to go here and then YouTube, Patran Nastran, or let me just put it out in here. It's fine. So now I have this blue window. So that's what you're supposed to have. I'm going to go on the geometry. I'm not going to waste any time. So geometry here. And before you go, you click here, you have create on the right side. And then I'm going to go directly on solid. Okay. I'm going to create by this way. You have different ways. Method, I'm going to take the as I want to have a box, so let me take XYZ, okay? So I'm going to put the value myself. So first of all, I'm going to consider that our, let's say, our length is the X1, right? So the length is going to be 200 millimeter, and the Y is going to be our width, 20, and then here we have our height is going to be 10. Okay, then we click apply. So if you do this, you can see, right? You go on home and you click this one, the smooth. I mean, it's going to enable you the full geometry so you can visualize it. Okay, so this is what I have. This is my cantilever beam. Okay, here the left side and the other side is the right side. So what I can go right now is the, let's go for the meshing directly, okay? So I think the mesh is very important step. Let me go here to a mesh seed. I'm not gonna click mesh because I need to define the elements. So let's go mesh seed. And here, instead of go number of elements, I will go element length to use sizes. As I am using millimeter, I'm going to put 5 to tell the software that the size of the element needs to be 5 millimeter. So here I'm going to click the whole geometry. You need to drag it, all of it, and then you hit apply here. So yeah, so you didn't need to put apply because you have the auto execute here, okay? So if you have the auto execute, directly when you select it, directly it assign your number of elements, but it's fine. So now I will put mesh here. And if you put mesh, as I have a solid element, I'm not gonna keep quiet. This is not very adaptable. You know, this you use the quad when you have a two dimensions, plate, all that kind of stuff, but solid element is better to go on trial. But first of all, here, not surface. Okay, you go solid and then you have the text. Okay, that's what you use. But if you put surface, you can see here it changes, either it's quad or trial. So you go solid, and now it will propose you what you will use on solid: hex, wedge, and tet. Then you pull the tet mesh 10. I think this is fine for me. Everything is fine. So I just need to select everything, but let me just hit the apply. So I didn't assign, I think. So create mesh solid, and then I need to assign here. So you select it. You can even click it like that, or type it here, or click it. So you have solid one here, and then apply. You can see you have your mesh. So go on home and you click this, or this one, you can see the mesh. Okay. Yeah, so this is your mesh. I click this one, yeah, or the equal, so everything is okay. So now, as we have our mesh, what we can go is the boundary condition and loads. So what are we going to apply? Okay, you can also go on material properties to create your material first, but let me go on loads. So what I know is I want to put a displacement on the left side here to support my cantilever beam. So displacement, you write here, let's say support. Okay, input data, I want to put a fixed support. So it's gonna be 0, 0, 0, because that's a fixed support. And then here is going to be as well 0, 0, 0. So you block all translations and all rotations. You click here, and then you take the surface. But as you can see, when you click, you don't have the surface, but the whole solid. That means you need to go here and change and take surface. So then you can click add here, okay, and then apply. So you can see that your cantilever beam is supported on the left side. And then we will apply the load. So the load is going to be force, okay? So force here, and then you give a name. It's going to be force, input data. So I will apply on the z-axis, okay? So the x and y is 0. On the z-axis, let's say 1,000 Newton, okay? 1,000 Newton, yeah, here, on the z-axis, you can see here the z-axis that is coming from, but I want it to go in that direction, okay? So let me just put the minus, and then okay. Select application region. Let me select this face, add, okay, and apply. So you can see the arrow, is going like that, So now we finish with our loads and boundary condition. Let's go on material. So what kind of material? Isotropic, anything. So let me go steel, because that we are going to click steel. Let's go input, elastic modulus, let's say 210,000. So that's steel. Fission, Poisson ratio is 0.3. Okay, no need of density. You hit apply. And then you go on properties. Now I'm going to assign this material. So it's a 3D, of course, solid. Let me say properties. Okay, then input properties, you hit here, and then you take the material created, and okay, select application region, you click the whole solid, add, okay, and then you apply. So now everything is okay. So let's go directly on analysis. We don't have to go load cases because we only have one case. So analysis. So here is the very important step. Okay. So first of all, we need to go on solution type. So we are performing a nonlinear static. So let's hit here, nonlinear static, and we can go on parameters. So here on parameters, we can see that the large displacement is already activated. So this is great, because if you hit this one, you don't have large displacement. So nonlinear static analysis is not good. You're not going to have the large displacement, large deformation. So you may not have results that are going to converge. So you need to have it activated. So this is fine. So the other things as well is to go on the steps, So, but I don't think it's in here. I think we can go on here, the subcases, and then you go subcase parameters. So this is where you will have the increment and stuff. So the increments, let me say 10 to 20. So we can take even 20 or 15. But if I take 20, and then let's go total time here. So total time, let me go 100. Okay. Now, okay. Then apply, and everything is fine. Cancel, and then you go apply. Yes. So now we have results. Let's go on access results. You click here, select results file. You can see it here. This one, nonlinear static analysis. You take it, apply, and then you hit results here. You click it. So now I have everything. Let's say we want to show the stresses. Okay. So nonlinear stresses here. And then you click displacement translation, or you hit OK, and then you can see it's very deflected, very. The next tutorials, I'm going to make comparison between the nonlinear static analysis and the static analysis, and show you the graphs to see the difference, Now we also show the results and plotting the displacement versus the loads, and then you can see the real difference. Okay, so that's what we have for now. I hope that helps. Peace.